Alright, so we're going to finish up last half of section 4.1 today, which is on right triangle trig. And what we're going to look at today is solving triangles. Alright, so when they ask you to solve a triangle, it means to find 6 things. 3 sides, 3 angles. Now, in order to solve the triangle, they got to give you something to start. So you're never going to have to find all 6. In fact, I'm always going to give you 3 pieces of information to start, and you're going to have to find the missing 3. Okay, so it'll be a combination of sides and angles that you need to figure out. So I said I'm going to have to give you something to start. Well, there's only really 2 situations I can give you. Right? If I want you to solve a triangle, then I need to give you either a side and an angle. And now, I said 3 things, but if you're like, well, wait a minute, he just said 2 right there. He's giving us a side and an angle. But if we're solving right triangles, you've got that every time. So what does that mean? If you have a right triangle, you automatically know what? Yeah?
You have a side with 90 degrees.
You have a what with 90?
You have an angle with 90.
You have an angle with 90. So you got an angle with 90 in every problem. That's automatic. So I need to give you 2 things in addition to that piece of information. So either how long is one of the sides, how big is the other angle, or I could just give you both the sides. Okay, so we'll talk about both of these situations. One of these you never use inverse trig for. You don't have to. The other one, you do have to use inverse trig. So it's not like you're going to use inverse trig every time. Sometimes you do, sometimes you don't. So what we'll do is they're going to give us a bunch of information like that. Okay, they'll tell us some sides, they'll give us some angles, and we're going to make this chart that you see right there. So we're going to organize everything into a chart, and we'll also make a sketch. I think the sketch is helpful at first, so like if I say to you what's opposite, you can see it. After you've done a lot of these problems, you can kind of just visualize it in your head, like, oh yeah, if A is here, alpha would be here, so they're opposite. But it kind of helps at first if you make a sketch. So when we make a sketch, this is the triangle that we're always going to use. Okay, I'm going to draw just a generic right triangle. You can have it face any way you want. That doesn't really matter. What matters is how I label things. We usually label the sides with what 3 letters?
A, B, and C.
A, B, and C. C is usually the hypotenuse. And now, does anyone remember the Greek letter that we put across from A? Yep, Joe?
Beta?
Across from A.
Oh.
I think they start with the same letter if you write them out.
Oh, alpha.
Alpha, A, alpha. So we put alpha there, and then we put beta there. So that's the triangle that I'm going to use for every problem. I'll just erase whatever they give me and fill that in. Okay. So you can draw this however you want, as long as you always keep A across from alpha and B across from beta, and C is the hypotenuse. If you want to draw it this way, that's fine. Doesn't matter how you draw it. Okay, because our drawing is not to scale. Okay, so here's some information. They're giving us the length of a side, and they're giving us an angle. So they're telling us 2 things. And they want us to find everything else. All right, so first thing I'm going to do is draw a picture. I'm going to use the exact picture I have up above, except I'm going to fill in some pieces of information. So B is 2, alpha is 40, and that's all I can fill in. Everything else is just going to stay the way it is. Joe?
Are we just pretty much solving all the sides and all the angles?
Yeah.
Okay.
Yeah. All right, so now I'm going to organize all that information into a chart. Okay, so I just put the three sides in one column. I put the three angles in the other column. And notice how I set up the chart. A across from alpha, B across from beta, C across from the 90. That's exactly the way we drew it. I put boxes around everything I need to find. So when I'm done, I need A, I need C, and I need beta. Okay, does anybody see something I could find first that wouldn't really involve a ton of work? You probably could have even found it before we learned anything about the trig this week. Yeah, Justin?
The third angle.
Yeah, we can get the third angle. What would the third angle be?
70.
Okay, what do they all have to add up to?
180.
They'll have to add up to 180. So how much have we used up so far?
130.
130. So what's left to get to 180?
50.
50. So beta is 50. Okay, so that's the first thing. All right, now we have to find A and C, and it doesn't matter which one you do first. Let's do A. So I'm just going to circle in the picture what we're going to find. We're going to find A. To find A, you have to use two other pieces of information. Now, I would stick with using the 2 and the 40. I would use this, and I would use that. Technically, I could have used the 2 and the 50. The thing is, you need to use another side, and you need to use another angle. Why did I choose the 2 and the 40 rather than the 2 and the 50? Technically, could have done the 50. Yep.
So you know 100% that's right.
Yeah, we know what they gave me is right. So if I stick with using the information that was given, I'm safer than using something that I calculated, right? Especially if we wrote down beta was 70 and it was wrong, and then we use that wrong answer to get A, then A is wrong, all right? So the way I'm showing you to do it, you can get beta wrong and it would have no effect on A at all. So you could still get A right and you could still get C right, even if you get beta wrong, okay? So, but we have beta correct now. So let's look at what we've got here. We're using the angle that's the 40 degrees. Okay, so everything is from the perspective of the 40. Using the words opposite, adjacent, or hypotenuse. What's the name of side A from the perspective of 40? Yeah? It's opposite. So this is opposite. And now what's the name of the side that's 2 from the perspective of the 40? Adjacent. Every problem we do today is going to involve either sine, cosine, or tangent. You are not using secant, cosecant, or cotangent for anything. So we have to figure out, is this a sine, a cosine, or a tangent problem? Well, we want to know the opposite. We already know the adjacent. So which trig function has opposite and adjacent in it? Yeah. Tangent. So this is a tangent problem. All right, so now to find, we'll be finding A. We're going to write down the tangent of, and I have to look at my angle, tangent of 40 degrees, equals, tangent is opposite over adjacent, A over 2. And that's the equation I need to solve to figure out A. So how would I get A by itself there?
Multiply by 2.
Yep. Multiply each side by 2. That's gone. Multiply by 2. We need to type that in on the calculator, but that's the answer for A. 2 times the tangent of 40. Now, is this a degree or a radian problem? Yeah, how do you know? Well, angles can be radians too. Yep.
There's the graph is in degrees.
Right. Look at the units. The degree symbol is on the 50 and the degree symbol is on the 40. So this is a degree problem. In fact, they're all going to be degree problems today. So put it in degrees, and then 2 tangent 40, and we get a length of 1 point, we'll go to 3 decimal places, 678. 1.678. Okay, any questions on that? So now last thing we gotta find is C. Now, this is a right triangle. So once you know 2 out of 3 sides, what theorem can you use to get the third side? Yep.
Pythagorean theorem.
You can use the Pythagorean theorem, but why do you think I'm going to say that's not a good idea? Even though you could do it. Kind of talked about this already before. Joe?
Since it's a decimal, if you multiply that, it's not going to have all the decimals in it to be the exact answer.
All right, so there's an accuracy concern because it wasn't 1.678. It was 1.678199262. So there's already, and the decimals go even further. They just go off the screen. So there's a rounding concern. But even worse than that, what else could have happened? Yeah?
You're assuming that A is correct.
Right. If I made a mistake on A and I use it to find C, well, guess what? Now C is wrong. So I'm going to forget about A. I have it. But now I'm going to find C. And I'm going to go back to the 2 pieces of information that were given. 40 and the 2. Right. So now I'm focusing on everything that's in black. So one of the sides I circled, we've already used before. That's adjacent. But C, that's a new side. So what's the name of that side? Yeah?
Hypotenuse.
That's the hypotenuse. So now we have to ask ourselves, okay, are we using sine, cosine, or tangent? To figure that out, look at the side that you know, look at its name, look at the side you want to know, look at its name. We know the adjacent, we want the hypotenuse. Out of sine, cosine, and tangent, only one of those has adjacent and hypotenuse in it. Yeah?
Cosine.
Cosine. So to find C, we use cosine. It's going to be the cosine of, what's my angle? 40. Cosine of 40. Always fill your angle in right there. Equals adjacent over hypotenuse. Adjacent is 2. Hypotenuse is C. Now, this one, because the variable is in the bottom, we've got to do 2 steps. We're going to start out by doing the same thing. We're going to multiply each side by what's in the bottom. That'll at least get rid of that fraction. So now I have C times cosine 40 equals 2. And what would be my last step to get C by itself? Yeah.
Divide by the cosine of 40.
Yeah, we don't even have to figure out what the cosine of 40 is yet. In fact, I'm never even going to figure out what it is. I'm just going to type the whole thing in and get the final answer. So divide by cosine 40. Divide by cosine 40. And there's our answer for C. Now, if you look at what we started with right here, and look at what we ended with, all that ended up happening was the C and the cosine 40 switched places. So that's the shortcut that I'm going to use from now on. You can do it this way every time, but the shortcut is just to take the cosine 40 and the C and switch places. And you can do that with any equation. If you had something like this, if you've got a variable in the bottom, you can just switch what's in the bottom and what's on the other side. As the answer, x equals 2/3. Okay, that trick always works if it's set up like that. Okay, so let's see what we get. 2 divided by cosine 40. So that side is about 2.611. Okay, once you get your answers, a couple things you should check. Make sure that C is the biggest side. If it's not, that's a problem. C should always be the biggest. And then look at your smallest angle, and across from it should be the smallest side. So the biggest angle goes with the biggest side, smallest angle, smallest side. Okay. And that's it. That's how you solve it. Now, if you solve it and you're pretty quick and you have enough time, you could check your answer with Pythagorean Theorem. So if we did everything right, then 1.678 squared plus 2 squared should equal 2.611 squared. So I got 6.816 and 6.817. So they didn't come out exactly the same. Does that mean I did something wrong? No, it's just because of rounding. Okay, we went to 3 decimal places, so it's pretty close. 816, 817. So because they came out pretty close with Pythagorean Theorem, I would be pretty confident that everything is correct there. Any questions on that one? All right, so we'll try one more of that type, and then we'll look at the last type. So I'll start you off. What's the first thing we do here, just to kind of visualize the triangle a little better? So we're going to be asking questions about what's opposite and what's adjacent, unless you can see it all in your head. It might be helpful to, Savannah?
You can sketch it.
Yeah, why don't we just make a quick sketch? We'll put A, B, C. We'll put alpha across from A, and we'll put beta across from B. All right, so you can find anything you want in any order you want, because we're never using something we find to find something else. So you got to find all 3. I usually do alpha. I do the angle first because it's the quickest one. Yeah, Eric?
70.
Yeah, it's going to be 70. Because 70 plus 20 is 90, plus another 90 is 180. So there's your angle. All right. So now the next thing you want to do is pick B or C and look at the triangle and make sure you're always using the 2 pieces of information that were given. The way I make sure of that is in this diagram, I don't even write things in it that I calculated. The only things in this diagram are things I was given to start with. So you're always going to use the 6 and the 20, and then pick which side you want to do. If you want to do B, go like that, and now figure out the name of side B. Is it opposite, adjacent, hypotenuse? And then the side that's 6. Is it opposite, adjacent, and hypotenuse? And then pick your trig function. All right, so see if you can set up the equation to find B. Okay, you won't be able to finish it unless you have a calculator. And then see if you can set up the equation to find C. Okay, see if you can figure out those 2 trig functions. Okay, so let's take a look at the equation we set up. Let's do it for B first. So Christian, in terms of opposite, adjacent, and hypotenuse, what's the name of the side that we've labeled B?
That would be opposite.
Yep. Everything is from the perspective of the 20. That's the angle we're choosing. So that's opposite. And how about, Chris, what about the side that's labeled 6?
Adjacent.
Yep, it's adjacent. So now if we're finding B, that's what we want to know. That's the opposite. 6, that's adjacent. That's what we already know. So what trig function has opposite and adjacent? Tangent, yeah, it's the same as last time. It's not always going to work out to be tangent, but this time it did. So the tangent of, what do I fill in? Yep, the tangent of 20 degrees equals, and Skylar, what would be my fraction on the other side? B over 6. Okay, this is the case where the variable's in the top, so all I have to do is multiply both sides by 6. And I'm done. Okay, so B is 6 tangent 20. All right, if you type it in, make sure you're in degrees. 6 tangent 20. And you get 2.184. Remember, if it's a 5 or higher, you're going to round it up. 2.184. All right. So again, I asked this before, but you could use Pythagorean Theorem to find C. Why is that not the best idea at this point?
The decimal.
It's a decimal, so it's rounded, so there's a concern about the accuracy already. And you really don't want to use something that's rounded to find something else, because then you're going to round that. It's too much rounding. Yeah. Right, and why do you always want to stick with the information that was given? We know it's correct. So to find C, we're going to go back to what was given, the 6, the 20, and C. So we've got a new side that we're using that we haven't labeled yet with a name. So C, is that opposite, adjacent, or hypotenuse, Derek?
Hypotenuse.
Yep, that's hypotenuse. Alright, so now I look at the side that I know. That's the 6, it's adjacent. Look at the side I want to know. That's C, it's the hypotenuse. Which trig function has adjacent and hypotenuse in it? Yep. Yep, cosine. So could you set up that equation for me to find C?
It would be 6 over C, or the little cosine of 20,
Yep, always put in your angle.
and then equals 6 over C.
Equals adjacent over hypotenuse, 6 over C. Now, this is the case where the variable's in the bottom, so I'm going to use the trick, just switch what's in the bottom and what's on the other side. If you want to go through it the way we did the first time, you can also do that. But if you do it correctly, you're just going to end up with that. Any questions on that? Okay, so let's type that in, see what we got. Well, actually, before I type it in, I can tell you that it has to be the biggest side. So it's got to be bigger than 6. If I get an answer smaller than 6, something's wrong. But it can't be too big. All right? If you add any two sides together, they have to be bigger than the third side. So if C was like 100, that's impossible. That'd be like having a triangle like this. You'd have one side that's just way too long. So I know that it's got to be the biggest side, so it's got to be bigger than 6, but it can't be bigger than 8.1 because if we add the other two together, that has to be smaller. So it's somewhere between 6 and 8.1. Let's type it in and see exactly what it is. 6 divided by cosine 20. So we get 6.385. Exactly where I said it had to be. Okay, so I'm going to check quick. Biggest side is with the biggest angle. Smallest side is with the smallest angle. And not only do these two sides have to be add together to be bigger than the third, any two sides added together have to be bigger than the third. So if you add A and B, it should be bigger than C. If you add B and C, it should be bigger than A. And if you add A and C, it should be bigger than B. That's a quick check I look at in my head just to make sure nothing is really, really wrong. Right. Okay. Any questions on that one? Okay, so both of the problems that I started you off with were this type. I gave you a side and I gave you an angle. Have we used any inverse trig yet? No. So you never have to use inverse trig if they give you a side and an angle. Let's look at the two-side case. So now they're giving us A is 3, B is 2, and of course the right angle, that's always 90. Now, what can't you do here that you could do right away in the last problem?
Third angle.
You can't get the third angle right away. All right, so we're going to have to hold off on that for a minute. But there is something you can use now that I wasn't okay with using before, but I am now. What do you think I'm okay with you using this time? Yep, Scott. Yeah, why am I okay with Pythagorean Theorem this time? Scott?
Because you're trying to get C and A squared plus B squared is C.
Okay, but what about the numbers I'm using in the Pythagorean Theorem?
They're not decimals, they're like whole numbers.
They're not decimals, so there's no concern about accuracy. What else? Yep. I'm using information that was given, which guarantees what? It's correct. So everything you're going to plug into the Pythagorean theorem was given. Even if it was decimals and it was given, that's okay. It was given. So we know that it's exactly right. So let's find C. So we've got a squared plus b squared equals c squared. Now, since we're finding a length with these kind of problems, it is okay to put in the decimal. We're always going to round to 3 decimal places with these. Okay, I know the stuff last night we didn't. We left square roots. That's how we'll do that stuff. This stuff we'll round off. So I get 9 plus 4 equals c squared. 13 equals c squared. And Eric, how do I get c?
13. The square root of 13.
Square root of 13. Which I'm going to type it in and round it off. So it's about 3.606. 3.606. Now, Ephraim, am I going to use that 3.606 to find alpha? No. Am I going to use it to find beta? No. Why is it a bad idea to use that 3.606 ever again? Okay, so we've talked about that. It's a decimal, so it's not completely accurate. It's rounded. And another reason we don't want to use it? It wasn't given. I calculated it. Maybe it's completely wrong. So if it's wrong, we don't even want to bother with it. So we're not going to ever use it again. So let's make a picture and see what we are going to use. A, B, alpha, beta, C. I'm only labeling things in that picture that I was given. Okay, so you can find alpha or beta. It doesn't matter. So, Michael, which one do you want to find first? Alpha. So I'm going to circle what he said to find. I'm going to circle everything that was given. Now I'm going to name the two sides. Joe, from the perspective of alpha, the side that we have is 3 units long. Is it opposite, adjacent, or hypotenuse?
Opposite.
Yep, opposite. Christian, the side that's 2 units long, adjacent or hypotenuse?
Adjacent.
It would be adjacent. So now we're going to ask the same question, thinking of a trig function that has opposite and adjacent in it. So Kay, what would be a trig function that has opposite and adjacent? Tangent. So let's find alpha. So it's tangent of my angle, so tangent of alpha, equals opposite over adjacent. 3 over 2. Now, what's different about that equation? This looks a little different than any other equation we've done so far today. Yep. We're solving for the angle. So we have to get rid of a function. Right? To get rid of tan, you can't add, you can't subtract, you can't multiply, you can't divide. It's not a number, it's a function. So the only way to get rid of a function is with the opposite of that function. Like square, square root. Tangent, what's the function that undoes tangent? Yep.
Inverse tangent.
Inverse tangent. So we are going to take the inverse tangent of what's on the left, and we're going to take the inverse tangent of what's on the right. Just to make it clear, we're not multiplying anything there. I can't multiply by words. You can multiply by letters, you can multiply by numbers, not words. Same thing here. If that was your equation, you wouldn't say multiply both sides by the square root. That doesn't make sense. You can take the square root of both sides, but you can't multiply by it. Take it. Same thing here. Take the inverse tangent of both sides. Inverse tangent, regular tangent, cancel out. On the left, I have alpha, and on the right, I have inverse tangent of 3 over 2. So now take the inverse tangent of 3 over 2. Okay, you are not multiplying there. If you type it in as multiplication, the calculator is going to look at you like, what are you doing? If you just type in inverse tangent times 3 over 2, it's like, the calculator has no idea what you mean. So no multiplication there. Inverse tangent of 3 over 2. So we get an angle of 56 point, we'll round that up, 56.310. That's 56.310. And that's all right. Now, if I was running out of time and I quickly wanted to know beta, it should be this. It should come out to 33.69 because I know all the angles have to add up to 180. So it's got to be 33.69. But if you do it that way, you just assumed you found alpha correct. If you do that and alpha was wrong, now beta is wrong. So let's find beta the same way we found alpha. We're going to stick with the side that was given, the other side that was given, and beta. So now focus on the 3 things that are circled in black. Yeah?
Will the opposite and adjacent switch?
Yeah, we have to rename the sides now because you've just changed the perspective. You're standing at a different spot. Okay? You're standing at beta. That's not opposite. That's not adjacent. As Joe just said. Now that's opposite, or that's adjacent, okay, because it's right next to it. And 2 is opposite. Well, wait a minute, I've got the same 2 sides last time, they just switched places. So what trig function am I going to use again? I'm still going to use tangent. It's going to be the same trig function. So is it going to be exactly the same equation? Well, no. It can't be the exact same equation, then you get the same answer we just got before. Okay. So this time, tangent of beta equals, what's going to be my fraction on the other side? And now, it's 2 over 3 instead of 3 over 2. Other than that, it's exactly the same steps. Take the inverse tangent of what's on the left. Take the inverse tangent of what's on the right. Beta is the inverse tangent of 2/3, which should be 33.69. If it comes out to 33.69, then I know I'm right because I got the same answer doing it this way, and I got the same answer just subtracting the other angle from 90. If you get the same answer 2 ways, I mean, you're pretty sure you're right. So let's see what we got. Second, inverse tangent, 2/3, exactly what we got before. 33.69, positive it's correct. So that's how you can solve a problem where they give you 2 sides. First type, side and an angle, no inverse trig. Second type, 2 sides, you got to use inverse trig, and you can use Pythagorean Theorem. Because to use Pythagorean Theorem, you got to know 2 sides. That's exactly what they're giving you in that case. 2 sides. Any questions on that one? Yeah?
Are we going to have a review sheet for the test?
Yes. Let's see. So we got that one and then the word problem. Does anyone want to see another one of the type where you start with the 2 sides? And it's up to you. It's really the same as the last type. Everyone feels okay with that one? We're going to review one tomorrow too on the worksheet. Alright, so let's try this one. So it says you lean a 20-foot ladder against a house. The angle between the ladder and the house is 17 degrees. How high, basically, will the top of the ladder reach? Not how high could you reach, because if you're standing on the ladder, you might be standing on the ladder and be taller than the ladder a little bit. So I just want to know basically where the top of the ladder would be. Alright, so this is the kind of problem where I think you should definitely do something we've done in every problem so far. What do you think we should we should do here. Yeah, Sam?
Write like A, C, and like try to draw the triangle.
Yeah, let's try to draw it out and label some things and see what's going on. So, first we need the ground. Now I made an assumption. I made an assumption the ground is flat. Maybe that's not true. But if we don't assume it's flat, then it's going to be hard to solve. So the ground is flat. What else do I need to draw in this problem? Yep.
You draw the angle in between the ladder and the house.
So he said two things. I need a ladder and I need a house. And if I draw a ladder and a house, the angle will be drawn automatically. So I'm going to assume something else about the house. I'm going to assume that the house was built perpendicular to the ground. Right? I'm going to assume we don't have a leaning tower of Pisa kind of thing going on. Because if we did, then we're not going to have a 90. We're not going to be able to solve it with what we learned this week. So we'll assume that the building was built upright. And now we have a ladder leaning against the house. Okay, so here's my ladder. Yeah, it's not to scale. So just by drawing a house and a ladder, automatically there's a triangle. A couple things I need to label though. What can I label in that picture?
The angle between the ladder and the house.
Yep, and the angle between the ladder and the house, is that the angle at the top of the triangle or the bottom? The top. That's the ladder and the house right there. 17 degrees. And one other thing I can label in that picture. Yep.
It tells you the ladder is 20 feet.
Yeah, the ladder is 20 feet. So what I'm going to do now is just kind of take the house out of the picture and turn it into a problem we've been doing. 20, 17 degrees. Draw that. Perfect. And now what I want to find is this. The distance from there to right there. That's the height of the ladder, which is the height of my triangle. So this time, you don't need to find the other angle. It's not what they're asking for. You don't need to find the distance between the base of the ladder and the house. They're not asking for that. Just the height of the triangle. Okay, so they gave me that. They gave me that. There's the two pieces that were given. That's what I want to solve for. So Dylan, what trig function would I use here?
Cosine.
Cosine. So I agree because that's adjacent. That's hypotenuse. So can you, Dylan, can you set it up for me?
Cosine of 17 equals C over 20.
Cosine of 17 equals...
C over 20. Oh, yeah, A over 20.
Yeah, we used A. So A over 20. Multiply both sides by 20. And that is how high the ladder will reach up the house. So 20 cosine 17. So 20 cosine 17. So it reaches up pretty high, about 19.1 feet. 19.1 feet. Okay, any questions on that one? Okay, so that pretty much finishes up the right triangle trig. So I'll give you a little time to start the homework. If you need calculators, they're up here. Just check them out. And then tomorrow we'll do a review of everything from section 4.1. Okay, I'm not going to focus as much on 3.1. 3.1 is on the test, but the review tomorrow will just be what we did today and the second half of Tuesday. So the homework, it's on 255. It's 31 to 39 odd, 43 and 47, and 51 to 55 odd. Okay, don't forget, I will be after school tomorrow, so if there's anything you need to make up from the test 2 weeks ago, tomorrow is the last day to do it after school.